Okay, take 4. Okay, so here we go. I'm going to make it this time. I'm going to make it through the whole thing. Okay, so just as a review of what I did for this lab, I have my box with my sides labeled, right? And I have element A, I have element AB, and I have element ABC. And the way this works is I shake the kernels around and I pull out the kernels that point toward A. Okay, and I make a list counting down from 50. Okay, then I do the exact same thing. I put all 50 kernels back, I shake it around, and I pull the kernels out if they're pointing at A or B. Okay, so the probability of pulling out a kernel is going to go up. Okay, I do that all the way through, counting down from 50. Okay, then I do it again. Okay, and I pull out the kernels if they're pointing at A, B, or C. So the probability of pulling out a kernel is going to go up. Now the whole point of this is I don't know when this kernel is going to point at B. Let's say this is the 25th kernel, halfway through. This is the, let's just say that I don't know that this is the, I'm obviously not going to know that this is the 25th kernel, but let's just say that is it. Okay, at some point, I'm going to touch that kernel. Okay, do I know when I'm going to touch that kernel? No, I don't. But at some point, I'm going to touch it. All right, so on this lab sheet, here's my data. Okay, and in order to figure out where I touch that 25th kernel, okay, I have to graph it. So this is the data. This is the graph. Okay, and if you look at the graph and how it works, the blue line is element A, the green line is element AB, and the red line is element ABC. So for element A, when did I touch that 25th kernel? Okay, it's right here. I touched that 25th kernel about halfway through turn 3. Okay, so if every turn represents 1,000 years, okay, that is 1,000, 2,000, 2,500 years would be the half-life of that element, because that's how many turns it took to touch that 25th kernel, to get halfway. For element AB, it's going to be a shorter half-life because the probability goes up that you're going to be pulling kernels out. So right here, I touch that 25th kernel. Okay, so that'd be a half-life of 2,000 years. And for ABC, the probability goes up even higher, and it's at 900 years. So in radioactive decay, the higher the probability that you pull out an element, or the higher the probability that an element is going to decay into another element, the lower the half-life. Okay, so, and that's what your interactive notebook assignment is on. It's not nearly as complicated as this, but you are going to graph to figure out the half-life of 4 different pretend elements. Okay, so the first thing I need you to do is copy this graph down. It's ISN graphing radioactive decay. Okay, I need you to copy this graph down. Okay, this graph would have been given to you in class, but I can't require students to print stuff. So you're going to have to copy this down. Make sure the axes are right. It doesn't have to be perfect. You can just eyeball the columns. You just have to make sure that it's 4, skip 1, 4, skip 1, 4, skip 1, 4, skip 1, 4. Okay. If you want to make it all super perfect and hardcore, the distance between these these lines are 1/4 of an inch. I calculated it out, and that's why it looks so even. But go ahead and pause the video and go ahead on the graph and go ahead and copy down the table down here. Okay. Okay, attached to this assignment is the data. Okay, so Hassium-90 is obviously a pretend element. Okay, so the reason why you need 4 is you're going to graph, you're going to make bar graphs of these elements. Okay, so Hassium-90 at 0 years, there's 100% remaining. Okay, and that's going to be for all of them. So I have Hassium 90 colored blue. So the blue column represents Hassium, right? At 25 years, it's at 50. Okay, at 25 years, it's 50. At 50 years, it's 25. 50 years, 25. Okay, 75 years, 12.5. 75 years, 12.5, and just eyeball that, right? And then 100 years, 6.25. And again, you can just eyeball that. Okay, so the next one is Debauchium 14, and that color is orange. So Debauchium 14 is 100%. 100%, it's second one over. Okay. At 25, it's 60. At 25, it's 60. Okay, and then so on and so forth down the line. Okay, so you're going to color these in right on the edge of the dots. I'm sorry, at the edge of the columns, you're going to put a dot. Okay, and I messed this one up. You're going to put a dot, and you're going to connect the dots and make the same graph that I made during the lab. Okay, and what you're going to do, when does it cross that 50 line? I know this is pretty simple. It would have been more difficult in class, but you go across, okay, and it's 25. When does it, how many million years does it take to pass this 50 mark? So this is the abbreviation for million years, if you can believe it. That's the unit. Okay, so Hassium 90, what's its half-life? When does it hit that 50? 25 million years. And that's what you fill out down here. So you're graphing the data that's attached to this assignment inside your notebook, okay, and then you just color it in. If you don't have colored pencils, you can also use, for example, this could be, Hassium could be fully colored in, and then Debauchium could be something like, X's. And then Deucranium could be, hash marks or something like that. Okay, so you can use symbols as well if you don't have colored pencils. But the whole point is just to label the graph, which color or symbol represents each element. Okay, go ahead and take a picture of that and submit it as your assignment. And thanks for watching all these videos. I know they were long, but this is pretty important stuff. It's going to lead into 8th grade as well. So thanks for hanging in there. Okay, thanks a lot, guys. Take care.